Everyone. Hope that everyone's doing all right, staying safe. Can you see my screen? Okay, so first of all, welcome. Today, we'll be going through 2 questions as usual, and the first one would be course schedule, which is this one that we're going to go through. Okay, so little survey. Would you like me to do it in C++ or JavaScript? Maybe I can just and okay, if you like it to be C++, you can give me a 1, and if you like it to be JavaScript, give me a 2. 1 for C++, 2 for JavaScript. And then we can get started with the coding. So while you guys are voting, you can just read through the questions first. Okay. So course schedule is a very classic question, a graph question. Okay. So there are a total of num courses I have to take, labeled from 0 to num courses minus 1. Okay. So for example, if I have a num courses of, okay, let's say if I have a num courses of 4, then actually I have course 0, course 1, course 2, and course 3, right? Starting from 0 to num courses minus 1. So I have a number of num courses labeled from 0 to num courses minus 1. Okay, and I am given an array of prerequisites where prerequisite at I equals to AI, BI. And this indicates that I must take course BI first if I want to take course AI. Okay, so what does this mean? Okay, I hope that you can see my Jamboard. Let me know if you cannot see it. Okay, so for example, if I have a if prerequisite at I looks like this, let's say 1, 3. What does this mean? It means that I have to take course 3 before I can take course 1. Course 3 is a prerequisite of course 1. Okay, I have to take 3 before I take course 1. So this is how, what it means by A1, B1. That indicates that I must take course BI before I can take course AI. Okay? So here's an example here, right? For the pair 0 and 1, I must take 1 before I can take 0. Okay? To take course 0, I must first take course 1. Okay, so they will give me a bunch of prerequisites, and I have to return true if I can finish all of the courses. Otherwise, I need to return false if I cannot finish all of the courses. Okay, so with this, let me just give you a quick example. Okay, by the way, if you don't understand anything, you can just let me know in the channel and I will address them. Okay, it seems like JavaScript is winning. We will see later, right after I explain the logic. Okay, so let's say I have this prerequisite array that has a couple of prerequisites. Let's say 1, 2, 0, 2, and 2, 3. So these 3 are the prerequisites. Okay, so given this prerequisite, can you tell me whether I can finish all of the courses? And just comment in the Leetcode Session text channel to say yes or no. Let's see. Anyone? Okay. So it's easy for you to see if there's only 3 prerequisites. So what if there's maybe 100 of them? It's very hard for us to scan it like this. So what we can do is we can form a graph and we can check for the graph. Okay, so here. So let's define our graph, okay? We will have an arrow, okay? And we can define it. We can define the one that is in front to be the one you need to take first. And the one behind you need to take after. So before and after. Okay, so in this case, following this prerequisite, right, I need to take 2 before I take 1. Take 0. Okay, and then here I have to take 3 before I take 2. So this would be my graph overall. Okay, as you can see, following this graph, I can just take 3 first, and then I can take 2. And then after taking 2, I can take cross 1 and 0. So I will return true because I am able to take all of the courses, right? So what if there is a set of prerequisites where I cannot take all of the courses? So for example, I have, again, the number of courses is 4. Okay, so label 0 to 3. And then with this, let's just make prerequisite to be 0, 3, 0, no, 0, 3, 3, 2, 2, 0. Okay. So this, I think this is one of the, yeah, if I did not write this wrongly, this would be one of the cases where I would return false, meaning that I cannot finish all the courses. So let's draw this graph out. So to take 0, I must take 3. Okay, so to take 0, to take 0, let's say 0, okay, I must take 3. Oh, wait, I need to draw it in the middle. Okay, to take 0, I must take 3 first, right? And here, to take 3, I must take 2 first. However, to take 2, I must take 0 first. And then we also have 1 with no requisites. Okay. So in this case, you can see that we have a cycle, this never-ending loop. Right? So if we go past this, like if we go past node by node, we will be stuck in a cycle. Right? As opposed to the one we did before here. So this one where we return true, we can actually go through all of the arrows and finish traversing the graph. However, in this scenario, we would always be looping in this 2, 3, 0 loop, right? So meaning that we cannot finish it. So what we learned from this, we learned that we will return false if there is a cycle in our graph. Because we need to take 2, only we can take 3. But we need to take 0, only we can take 2. But we need to take 3, only we can take 0. And we need to take 2, only we can take 3. But we don't have, we keep finding its requisite, but we cannot find like the first one we need to do to go to the end. It's a big loop. So what have we learned from this logic, this drawing lah? Okay, I would say this graph. So we learned that if it's true, okay, traverse the whole graph. Okay, let me just put it here. So I think that JavaScript is winning at the moment. Yes. Okay. So if we can traverse the whole graph, then it's true. And if there's any cycles, then it is false. Okay. So one thing that we can do is that we can construct this graph first. But how do we construct this graph? So we can create something called an adjacency list. Okay. Adjacency list. Somebody like to call it, some people like to call it adjacency map, adjacency matrix, but we just call it adjacency list for now. Okay, so for adjacency list, what we do is, okay, we record all that is next to it. Okay, so for example, I have 0, 3, 1, 2, and 0, 1, let's say, okay? So with this test case, right, to go to 0, I must start from 3, right? So the adjacency list for 3 is 0 for now. Okay, and here, to go to 2, to go to 1, I must go from 2. So the adjacency list of 2 is 1. Okay, to go to 0, I must go from 1. So this would be how the adjacency list works. Okay, if there are more prerequisites, right? So for example, to go to 0, I must finish 1 or 2 first. 1 and 2 first. Okay, so let's say if I have this additional prerequisite, then my adjacency list would look like this. 1, no, sorry, here, 0, and, oh, sorry, it should be for 1. It should be for, okay, here. So this is actually 2 to 0, right? So I should add it to the adjacency list of 2. Okay, so 2 can go to 1 or 0, meaning is this. Okay, so this adjacency list, we can actually convert it to the graph later on. So here 3 connects to 0. Here 2 connects to 1 and 0. Then 1 connects to 0. So we can make an adjacency list like this. We can traverse them. Okay. So using this adjacency list, I can start like, for example, I start from 3 and I traverse to 0. Then I find 0 from the adjacency list. Okay, there's no 0 from the adjacency list. I move to 2. And 2, I traverse to 1. So I find 1 in the adjacency list and I just traverse. I keep traversing it using a depth first search. All right. Okay. So in our logic, first, pseudocode first, create a adjacency list. Okay. Then second, we can do a depth first search, right? To go through all of them. So for example, I have a graph like this. Okay. So for example, I have a graph like this. So this should be true, right? Since there's no cycles, I can just take one. I can take cost 1, cost 2, and cost 3 first, right? And then after I take cost 1 and 2, I can take cost 4. And after I take cost 1, 2, 4, and 3, I can take cost 0, which finishes all of the costs already. Okay, as you notice, there's no cycles here. So how can we check if there's any cycles, right? So while we are traversing at one time, we need to check if the thing has been visited or not. So for example, if we have a cycle here, okay, so if we have a cycle here, okay, maybe I start from 1, okay, and I would have a visited array to record like the visited nodes, okay. So I visited index 1, so I would just put true at index. I'm visiting index 1, so I would just put 1 as visiting. Okay, 1 equals to visiting. And then I move on to visit index 2. Okay, so all of these start with 0. So I'm visiting 2, so I change this to be visiting. Okay, and I'm visiting 3, so I will change index 3 to be visiting. Okay, 1 equals to visiting. This is self-defined. Okay, next I am going to visit 4. So I will change index 4 to be visiting. Now I go back to index 1 and I check it is already visiting. Okay, if it's already visiting, then meaning that I'm in a cycle. Okay, so I will check if already visiting. Okay, if I'm already visiting, then it's in a cycle. Okay, so what I can do is I can set 1 as visiting. But how about in this scenario? Okay, in this first scenario where we return true. So let's say I will do a depth first search on 1 first. Okay, so here okay, I have this 0, 1, 2, 3, 4. This is my visiting array. Okay, so first I am visiting 0. Okay, and I'm visiting 0. There's no other nodes for me to visit, so I visited 0. right? So when I'm visiting 0, it will be a 1. But after I visited 0, I need to change it to something else to show that I have visited that node. So I'm just going to change this to a 2. Okay, so 2 meaning visited. Okay, now I will go on to node 1. I will do a depth first search on node 1. Okay, so I'm visiting node 1. So this will be a 1. Next, I will be visiting node 4. Okay, so 0, 1, 2, 3, 4. So node 4 will be visiting at this moment. Okay. And then next, I will go on to node 0. I see that node 0 has already been visited, meaning that the course has already been taken, right? So I can just ignore it. So this is the significance between visiting and visited. Visited meaning that I have already finished this in a previous depth first search, whereas visiting is that I am in the same depth first search and I have found a cycle. So this is one of the, I would say, core concept of graph traversing as well. Usually, if we want to check if there's any cycles, we would use a visiting, visited, use this concept basically. Okay, so the data structures we will need is an adjacency list, and we need to have a visit map sort of thing to record, right? Where for this visit map, 0 is equal to 0 would be unvisited, okay, and then 1 would be visiting. I know this may be a bit confusing because this is, I chose a more difficult question today. And then 2 is visited. Okay. So the thing is we need to check for cycles, right? So please remember that. Okay, so first I will be creating an adjacency list. Second, I will be doing a depth first search. Okay, and when I initiate the depth first search, I will mark as visiting because I am visiting, right? Okay, and then I will check for the neighbor nodes and mark them as visited as well. So after I visited it, I will just mark as visited. Okay, so while I'm checking for the neighbor nodes, if it's a cycle, meaning that if it's visiting as well, then I will just return false, right? Else it will be a true that I'm returning at the end. Okay, so this would be my overall logic. Okay. So we can start implementing this. Okay. So first of all, I would be creating like a visit array. Okay, so that visit. Okay, and I would also be having an adjacency list. Okay, so let me just call visit to be an array. Okay, an array of number of courses, right? And then I will fill it up. I will fill it up with the value of 0. Okay, so remind you again that 0 equals to unvisited because at the start all of them are unvisited. Okay, so visit equals to. Right? And then I would have my adjacency list. I will make a map for this. Okay. So now let me just create our adjacency list first, right? So this is actually quite similar for all of the graph problems. So you can just like memorize how to do this. Okay, but basically I'm looping through all the prerequisites and I will get the first one. So remember, if it's like this, okay, for example, if it's like this, 1 to 2, okay, then in our adjacency list, we will record 1 with 2, right? And if 1 can lead to 2 and 3, then in our adjacency list, it will be 1 to 2 and 3, something like that. Okay, so I will search for if 1 is in the adjacency list at first. Okay, so I can just do adjacency list dot get, and I will find if this one that is before is in the adjacency list. Okay, and if it's not in the adjacency list, okay, then I would just set it to be an empty array. Okay, and then I would add this value into the edges. Okay, and then at the end, I will just set it to be the value of it in the graph. So this is my way of just, pushing them in. Okay. Right, so first I'm just getting this out, and then I'm getting it out from here. Okay, so if there's already any existing value, it would be retrieved here. If there's no existing value, then it would be an empty array. Then I will put this value in, and then I will set it again. Okay, so with this, I will be doing the depth first search now. Okay, so here I am just going through the graph. Sorry, it should be adjacency list in this case. I'm going through the adjacency list. Okay, so let me just call this A and B, or maybe first and second, before and after. Okay, before, after. Okay, so I'm doing this of the adjacency list. So I'm looking through the adjacency list, and I'm doing a depth first search for all of the before. Okay, so this is to prevent if there's any cases where they are separate paths. Okay, so for example, if your graph looks like this, 0 to 1, and then maybe 2, 3, then 4. If your graph looks like this, and you only do a depth first search from the first one, right, 0 to 1, then you will only cover these two, and the rest you haven't covered. So you have to look through all of them to make sure that all of them are visited. Okay. So I will do a depth first search here. Let me create my depth first search helper function. Okay. So I will just make it nested. Okay. So this depth first search function would take in a node. Okay. And it will search through its neighbors according to the adjacency list. Search through neighbors. Okay. So first, according to our logic, right? First, I will be marked as visiting, then I will check for its neighbor. And after I check for neighbor, I will mark as visited. So first, I will be marking it as visiting. Okay. So how do I mark it as visiting? I have this visit array, right? So maybe I should be, you know what, it's fine. Okay. So I will just mark it as visited. So visit at node equals to visiting, sorry. I will move this on top, I think. Makes more sense to do that. Okay. So I will be mark it as visiting. Okay. So the value equals to 1 means it's visiting. All right. And then I will get its neighbors. Okay, so let me just call this NB. Neighbors meaning that all the next node that we can go from there, right? So we can get it from the adjacency list. So we get from the adjacency list, and we get the neighbors of that node. Okay. And then we can look through the neighbor and recursively call the depth first search function. Right? So if there's any neighbors, then I will be going through the depth first search function. But for that, I need to go through each of the neighbors because there could be more than one neighbor. So let me just call these neighbors, and then I can do let neighbor of neighbors. Okay. So I'm going to do a depth first search. So if it's already visited, then I don't need to continue to search, right? Because it's probably visited at the last depth first search that we did. So if the value is 2, okay, so if visit at neighbor is equal to 2, means it's already visited, then I can continue. Okay, means I don't have to do a depth first search. And then else, if visit at neighbor equals to 1, meaning that I'm already visiting it and it's still here, meaning that there's a cycle, right? So I can return something. I think I'm just going to return true here. Okay, so means that there's a cycle. Let me just make this, sorry, let me just make this to be more readable. Make this to be an else if also, doesn't really matter. Okay, so there's a cycle. Here. Else, meaning that it's not visited and there's no cycles, then I will have to continue to do a depth first search to search through the other nodes. Okay, in this case, I will do a depth first search. Okay, so I'll just do the depth first search here. Okay, and I'll search for its neighbor. Okay, and if the depth first search returns true, meaning that, look, if there's a cycle, it returns true, right? So if this depth first search returns true, meaning that there is cycle, there is a cycle within one of them. So that's why it returns true. So I will just bubble up the solution, and I'll continue to return true back up. Okay. So here, right after I've visited this, right, I will mark as visited. Okay, so visit at node would be 2. Okay, so this is mark as visited. Here I mark as visiting. Okay, mark as visiting, and I will do the visiting. And if I find a cycle, right, then I have to return true. And after I visited all of the neighbors and there's no cycle, then I will just mark as visited and I will return false. Okay, I can also do the other way around, like return false if there's cycle and then return true when there's no cycle. Doesn't really matter. Okay, so here, maybe I should separate the function so it will be more easier for you. Let me just bring this depth first search function out. Okay, so I have this depth first search function outside of can finish, and I'll just move adjacency list and visit outside. Okay. Okay, so this is the same thing. I only moved the functions to be more cleaner. Okay, so in our can finish function, first we create our adjacency list. Okay, and then we will do depth first search for all of the keys in the adjacency list, right? So we will do a depth first search for before. Okay, and doing this depth first search, we will be checking if there's any cycles. So remind you that it will return true if there's cycles, right? So if this depth first search is true, meaning that it has a cycle, so I will return false, right? Okay. And then I will continue to check through all of the keys in the adjacency list. And then at the end, I will return true, meaning that there is no cycles. Yeah, I think I shouldn't have picked this question because it's quite lengthy and a bit complicated, but let's try to run through the test cases here. Okay, let's see. NB is not defined. Okay, so this should be NBS because we already changed it to neighbors. So if neighbors, actually, this is just to check if there's any neighbors. But if there's no neighbors, then it won't loop through here. So this if statement is actually kind of redundant. We don't need it. But it doesn't make our code break. Okay, let me try to submit this. Okay. 1 false. So I think that there is an edge case that I need to take care of. It's that, okay. So if there's nothing in prerequisite, then I guess I should just return false. Sorry, I just return true. Just get the I think that this shouldn't really matter. There could be some other bugs in here that is causing that. So if prerequisite.length is that's that one. I'll just return true. Yeah. So there is an error with this, but I'm really running out of time. I think that maybe I can use this hour if Marcus, is that okay with you? And then you can just use the whole hour for next week. Okay. I picked like a more complicated question today. Okay. So let's just try to debug this to see if there's any issues. So first we create visit and our adjacency map. Okay, no problem with that. And then here, I will initialize our visit to be the length of num course. Okay. And then here I will be going through our prerequisites to set up the adjacency list. Adjacency list. Okay. So for VE of prerequisites, okay, I will let edges to be, I will get E from the adjacency list. Okay. And if I get nothing, then it would just be an empty array. And then I will push V into it. Right? And then I will set adjacency list of the key E to be the values of edges. Okay, so this is the adjacency list setup. No problem here. Now I'm doing a depth first search. Okay, and I'm going through the adjacency list. So I'm getting before and after, and I'm going through a depth first search with this before. And I will return false if depth first search is true, meaning that if there's a cycle. And then at the end of everything, I will just return true. Okay. And then here, I'll be searching through the neighbors. So first, I will be marked as visiting. Okay. And then I'll let neighbors to be the neighbors that we set in the adjacency list. Okay. And then we will go through its neighbors. If visit and neighbor equals to 2, then I will continue. Right? I will just skip if it's already been explored. And then if visit at neighbor equals to 1, then I'll just return true, right? Because there's a cycle. And then else if this value is true, okay, the first search of it is true, then I'll return true because I have to recursively bubble up the answer. Okay. And then after all that, I will be marking it as visited, and I'll return false for this. Okay, so by right, this shouldn't be an issue. If this is, then I will just continue. This is it, this is this. Okay, so one thing that I can think of is maybe that here, we should actually just go through the numbers from 0 to num courses minus 1. Okay, as I've mentioned here, right, if we go through only 0, then we don't know, right? So we need to go through all of them. We try to go through all of them to find any cycles. So to go through all of them, we can just loop. Okay, so let course equals to 0, and then course is less than num courses, and then course increments. Then I would just do a depth first search for course. So if a depth first search of course returns true, then I will just return false. Okay, another thing that I can think of that may be causing error is this if-else statement, but let's try this first. Okay, let me just comment this out, because by right this is not needed. So let me just run the test cases first, and then let me submit this. Okay, so there is an error here. So another thing that I can think of is that maybe here we should use if, because usually I use if for these. But honestly, I don't think that there should be any issue with this. If the first search of neighbor is true, then we will return true to bubble up the solution. And if visit is equal to 1, meaning that we are in a cycle, because 1 equals visiting. Okay, so this should be true also. And then if visit of neighbor equals to 2, then I will continue. Okay, so meaning that 2 meaning that I've already visited. That's why I continue. Let me try this. Okay. So anyone have any idea as to which part is wrong? It seems correct to me. Okay, so here I'm outputting false, but I'm expecting a true. So I'm doing this depth first search. Of 0. I have this adjacency list already, and I'm doing the adjacency list setup. This is correct because I'm taking this, which is the first one, and then I'm pushing the second one in. Okay. And then here, I'm going through all of the courses, and if the first search of course is true, then I'll return false. Else, I will return true. Okay, and here, first I'll be marked as visiting, and then this for let neighbor of neighbors. If visit neighbor is equal to 2, then I'll continue. If it equals to 1, then there is a cycle, so I'll return true, and this will bubble up the cycle to be true. And I'll just set this visit to be 2 because I have visited already, and then I will return false at the end. 1. Okay, not very sure actually, to be honest, but let me try using this prerequisite again. But prerequisite, sorry. Let me try using the graph, the adjacency list. So I'm taking the first value of the adjacency list. And if the first search of that is true, then I will return false. And at the end of everything, I will return true, meaning that I've never met any cycles. Okay. So by right, this should be correct. Let me try to submit this. Gives me this. I'm taking this node and I'm setting it to be visiting. Okay, I'm setting it to be visiting, and then I'm getting its neighbors. Okay, and after I get all the neighbors, I will go through the neighbors, okay, NB of NBS, and I will check if the neighbor has been visited. If it's visited, then I'll continue, and I'll check if I'm visiting the neighbor. And if it equals to 1, meaning that I'm already visiting, means that there's a cycle, so I'll return true. Okay, and if that first search neighbor is true, meaning that I have cycled before, that's why it gives me a true here. And I'm just bubbling up the true, the solution of true. And at the end, I'll just mark as visited, and I will return false. Kind of weird. I guess I can just see like before when I did it, how I did it, and then we can see like the differences between them, I guess. So let's see how I did it last time. No, this is not a good one. Okay, let's try this one. We can do comparison to see where I did wrong this time. Okay, so this is what I did the last time. I create this graph, and then I have this visited, right? 1 equals to visiting, 2 equals to visited. It seems the same. Okay, and then here I set up the adjacency list. Okay, I get the value of E or empty, and I push V. Okay, and then I set it to be E to be edges. Okay, here I'm doing the depth first search. I'll be searching all of the values in the adjacency list. Here I call it graph. Okay, and then if cyclic, then I'll return false. At the end, I'll return true. And this is my depth first search function. I'll set as visiting. I'll get all the neighbors. And then I'll go through its neighbors. If it's explored already, then continue. If equals to 1, meaning that it cycles, so I'll return true. And then if it's true, then I'll just bubble up the solution to be true. And then I'll mark it as visited. It looks correct, actually. I think it's same as the one I did before, but somehow this doesn't work. Maybe they have already updated the test cases and I did something wrong here. Let me try something. Let me just try to copy and paste this up there. Just try to submit this to see. So this is weird because it seems to be the same to me. Okay, let me just. This was my solution, and this was the correct one. What time is it now? Okay, we have another 15 minutes. I think that there may be like a bit of a typo or somewhere in my for loop or whatnot that like made it wrong, but this is the overall concept. So I will be putting this on a GitHub instead of like the one I did just now, because that one has a problem that I cannot find out where your girl is blind. But yeah, we can go through this again, and I can draw it out to make it more easy to understand. Okay, so let's get a test case. No, this is not a good one. Okay, let's get a test case of maybe 1, 0, 2, 0. Okay, so this is actually just 0 to 1 to 2. Okay, we can have another, sorry. And we can have also another that is 3 to 2. Okay, so 3 goes to 2 also. And 2 can go to 4. Okay, so this would be our test case. All right. Okay, so this is the graph. Okay, so we will be checking if there's any cycles here. So first, we will create our adjacency list. Okay, so our adjacency list, our adjacency list will look like this. Okay, so here, 0 goes to 1. So for 0, we have 1. Okay, and then here, 0 goes to 2. So we will add 2 into our adjacency list as 0. So this is actually a map, right? So the key is here and the value is here. Okay, 3 goes to 2. So 3 has a value of 2. And 2 goes to 4. So 2 has a value of 4. So this is our adjacency list, okay, which is just a map, and these are the keys and these are the values. Okay, so now we are going to do a depth first search, okay, for all the key value pairs. So I'll be doing a depth first search, and I will start with this key 0. Okay, and remember we have our visit array as well. Okay, so in my visit array, I will have index 0, 1, 2, 3, and 4. Okay, index 0, 1, 2, 3, and 4. So all of them will start with a value of 0 because all of them are unvisited at start. Okay, so I will start my depth first search with the key 0. Okay, so first in our depth first search, right, we will be marking it as visiting. So the visit value for 0 would be 1 now. Okay, and then we will go through its neighbors. So its neighbor, we have neighbor 1 or 2, right? So let's go to neighbor 1 first. Okay, so we will be visiting neighbor 1. So let me just change this to visiting, which is value 1. Okay, now 1 doesn't have any neighbors anymore, right? So if we follow our logic, when there's no neighbors anymore, we will just change it to visited and we will return a false value. Okay, so here I will be change this to visited. So 1 would have a value of 2. Visit at index 1 will have a value of 2. Okay, because it's visited. And then we backtrack up here. We already checked 1, so now we need to check 2. Okay, so we go to 2 and we are visiting it, so it will have a value of 1. Okay, and we need to check for the neighbors of 2. So 4 is a neighbor of 2. Okay, so we will be visiting 4. Okay, I will change this to visiting. So value is 1. And since it has no neighbors, so when it has no neighbors, it will go down and be marked as visited. Okay, so value will be 2. Okay, then after this is finished and I go back up here, I have no more else to visit, right? So this value of 2 would be changed to visited as well. Okay, and I backtrack up here to 0. Since there are no more neighbors for me to visit, I will set it as visited as well. Okay, so this would be 2. So my depth first search, I started with 0, right? Now my depth first search goes to key 3. Okay, so when I go to key 3, which is here, so again, I will do the whole thing again. So first, I will make it to visiting, sorry. Okay, and key 3 has a neighbor of 2. So I'll go to index 2 and I check that it has already been visited. So I continue. I don't do another depth first search. Okay, and since key 3 doesn't have any more children, so it is visited. So I will change this to value 2. Okay, now that I've already depth first searched for this key 3, I will go to the last key the last key value in the adjacency map, which is 2. So when I go to index 2, I immediately find out that 2 has already been visited, so I don't continue to do the depth first search. And with that, I've already finished my whole depth first search and I found no cycles. So I will just return true. So in the event that I found any cycles, I will have encountered a 1. So I guess I can do a scenario where there's a cycle. Okay, bear with me guys, I know that this session is not perfect, especially with our error just now. Okay, let me just make this to be, let's say 2, 0, 0, 1, 0, 2. So our graph will look like this: 0 to 2, 0 to 1, and 2 to 0. So there is a cycle here, and we will see how we can detect this in the map. I think we can make it to a big cycle so it will be easier for you to see. Okay, so let me just change the test case a bit so that the graph will look like this. Okay, 2 to 1. Okay, we have this big cycle. Okay, so first in our adjacency list, it actually is just 0. The key of 0 would map to 2, and the key of 1 would map to 0, and the key of 2 would map to 1. 0 map to 2, 2 map to 1, and 1 map to 0. So this would be our adjacency list. Let's start with our depth first search. So our depth first search will be going through all of the key values, right? In this initial depth first search, we are going through all of the key values in our adjacency list to find out if there's any cycles. Here, start with this 0 value, okay? So I have this visit array as well to store how many to store like the visited status for the nodes. So first, all of the value will be 0 because I have not visited any of them yet. Okay. So let me just do a depth first search for index 0. So first, I'll be visiting index 0. So I would set index 0 to have a value of 1, okay, to signify that I'm visiting it. Okay, and the neighbor of 0 is 2. So I will go to index 2 and I'll set it as visiting. Okay, and I will go to find the neighbor of 2, which is 1. So I go to index 1 and I set it as visiting. Okay, and for 1, the neighbor is 0, right? So I'll go to 0. And you see here, it's already 1, so there's a cycle. So here we will just return true for the cycle. All right. Okay. So here I will return true. And I'll return up here. So if depth first search of E equals to true, then I return true, right? So I will just keep returning true up here, up until the top. And then I'll just return true for the solution overall. So this would be the solution for course schedule. It is a combination of, actually it's not a combination, this is actually just graph. Okay, I'll look at this later and see if there's any errors. But basically, what we did here is that we are doing a graph problem and we are solving it using depth first search. Okay, this is a directed graph that has cycles in it and we need to find out the cycles. So what we do is we create an adjacency list and we check for each of the value in the adjacency list and we do a depth first search to check if there's any cycles. Okay, so usually for cycles we do depth first search to check. Okay. And yeah, this is basically it that we can do. So first, we set it to visiting, and then we check all its neighbors, and then we set it to visited. And within, when we are checking the neighbor, if it's already visiting, then there's a cycle. So I'll just return something, and I will bubble up the solution. All right, I hope that this wasn't too confusing. I apologize for the, for the bug just now. Okay, but yeah, I hope that you at least learn something. At least you learn how to like set up an adjacency list, or I don't know, read map, no, like read graph questions, I guess. Um, yeah, so this is on my side, right? It's my bad that I chose a question like this. So for next week, I will be choosing a more appropriate one, cover in 30 minutes. Yeah, so thank you so much for attending today's session, and see you next week.